going to go to modules. I'll check it in just a minute because I was working on. Oh, lovely. Okay. Give me just a minute. Guys, you need to be seated. Just sit down. Sit down. All right, in just a minute, you're going to read. Oh. All right, refresh the attendance page. Choose the 16th you should see now. Places. Where can you find water on Earth? You can name me one. Ocean. Lake. Lake. Rivers. Streams. So that comes from clouds, and it falls in rain. Groundwater, so under the ground. So pick you some of these, type in, put submit. And then once you click submit, we do not need underground springs. Once you click submit, you do not need your phone book anymore. You'll need a pencil and packet that I've given you. You want to cancel questions if you are here and not going to have to do this remotely once I can get it up remotely. Mari, do you have something to write with? I probably won't be with the one. Okay. Or if they're online. And once you submit the attendance, you can have a seat. Yeah, write your name because I will give you participation points for filling this in today. And so I'll have, once Cammy's up and running, I'll have the one online available for the notes. The PowerPoints will be online. All right, this is a little complicated how to follow the sheet, so I'll try to tell you as we go along where to put information. But it'll be. I already had this one. This isn't a web list. This is notes. Well, I already did this. Did this like on. I can never remember which. I also did this saltwater stuff. Well, this was on an attendance. Yeah, I know. Because it was within a web quest. Yeah, I know. But this is, we're just backing up and doing some notes today. Kind of going a little bit old school. All right, so I'm curious. I want to present and I want to see what will happen with my recording. Is it going to show it? Okay. All right, so keep it big. So just to review, so this first page is kind of a review. Everything that's living needs water. So you need to list under the bullets the ways we use water. So ways humans use water up here at the top. We use it for drinking, so we need water for drinking water. We need for recreation, for food, for agriculture, and hydroelectric energy. Yep, it has it there. That is like our the dams that we have. I know. I think there's one at Baden Lake, and there's one at Lake Tillery, and it's how we get our electricity. So the water that runs through those dams help produce electricity. All right. So most of Earth's water is salt water. So out beside salt water in that chart, you're going to put 97.5%. That's not what online says. It says it's 96.5. You're going to have a very, I mean, it depends on who does the averaging. Where the It's roughly 97. In other words, it's more than fresh water. So 97.5. is roughly, you may get it, you always may get one or two above or below. Statistically, that is acceptable. Fresh water is going to be roughly what is left out of the 100%. So depending on what you find for the salt water, the fresh water is going to be left, which is 2.5. This is the first block.
Oh.
Yeah, so I've had it all salted. All right, and then we have, so if you want to look at it a visual this way, you've got your oceans are the majority of that, which is the 96.5, but we have a little bit of other salty water that makes up the other 0.9%. Then you have your fresh water. Well, your fresh water, you can break it in this column. And look, the majority of it is in glaciers and ice caps. So ice, you're going to put 68.7%. So the majority of our fresh water is found in ice, glaciers or ice caps. Then you've got your groundwater, where's the rest, the majority, the next largest percent, which is 30.1%. You have lakes, which is going to be over here, 20.9%. Now, these are not going to all add up to that 1% because we're breaking them down individually. Rivers, that is going to be 0.49%. Water vapor, that's your atmosphere, 3.0%. May have been a better way. And all of those. So this is all different places we can find water. So salt water is mainly going to be your oceans. You'll have some other places that you may find some salty like water. You're going to have fresh water. It's going to make up the rest of the water, and it's going to be found in ice, groundwater, or some type of surface water, such as rivers, lakes, swamps, and the atmosphere. Notice they even have human beings up there. We have water, or living things, we have water inside us as well. So we'll make up a percentage. So this is just mainly to give you an idea. The exact percentages don't really matter. It's the fact that you know that most of the water is going to contain salt. And then where all can we find the fresh water?
We technically contain salt water, but we don't die from it.
All right, so look in the middle section. Water moves on Earth through a continuous process called water cycle. Is already spelled out for you there? Water cycle. We're not flipping the page yet.
That's where ours is.
So I'm going straight down this front page. This middle section has the words water moves on Earth. The continuous process is a water cycle. Then it has water cycle. Hyphen. You're going to write out the circulation of Earth's water. We're not worried about the next page yet. Throughout the side water cycle, the circulation of Earth's water. Everybody have that? Circulation of Earth's water? Then we're going to talk about each piece before we flip over. So this should be just a review. All right, circulation of Earth's water. You got it? All right, so In the chart below, you start with evaporation. Remember, evaporation is liquid to a gas, and there's the definition. That's what you go and put in that empty spaces. So you could shorten it and say water is turned into water vapor and rises to the atmosphere.
Why do you sound like you're outside the country?
Because I have a mic going.
No, that sounds like it's coming from home.
I don't know. It could be this, because I'm got myself up here. It could be that you're hearing some from here. It has to do with this mic being set up. All right, transpiration. You may not be familiar with this word, but this is how water from plants evaporate. So water leaves plants, the leaves of plants, and evaporate, and they give it a special name called transpiration. So evaporation from the surface of the earth to the atmosphere, transpiration from plants to the atmosphere. I'm getting ready to click. So I'm shortening it. Verbally, I've been shortening it. The evaporation is from the surface water to the atmosphere. Transpiration is plants to the atmosphere. Okay, we're going to continue with my mouth. All right. I've shortened it. I said water changes to water vapor and goes to the atmosphere. Transpiration, water from plants. Water goes to water vapor, goes to the atmosphere. Or water from plants to the atmosphere, water from surface to the atmosphere. I've shortened it. Get the shorter version down. I'm gonna need to move on. Yeah, still. Yeah. Kind of hard. You got a mask and talking, and the heat's going. We can't. It's the school board rule. All right. Condensation. The next one is when a gas goes back to a liquid or a gas goes to a liquid. I had been saying it multiple times. It was on the previous slide. Right here. From plants to the atmosphere. From plants to the atmosphere. All right, condensation is how we get our clouds. You've got water vapor.
Basically, so what you're saying is gas goes to a liquid.
Gas to a liquid, yes. Condensation is gas to a liquid. What happens is when this water vapor warms up enough and it collides with particles in the atmosphere, then it condenses into water droplets. So gas to a liquid, water vapor to a liquid for condensation. Yeah, the same thing. Water vapor and gas is same thing. We don't need our Chromebooks right now because we're on this. Andy's not working, so we can't do any of the other stuff online. All right, precipitation. Precipitation, you can just write down snow, rain, sleet, hail. Snow. It doesn't have snow, rain, sleet, hail. It does have the next part. So a decrease in precipitation decreases the amount of infiltration. That just means the soaking of water into the ground. And for infiltration, all you're going to put is, you could say water soaking into the ground, water seeping into the ground. In other words, water on the surface is getting into the soil. So that'll go above the bullet that's already there. So you can shorten it. Then you're going to flip your paper. You shorten that. Infiltration. It's here. Surface enters the soil. You could say water seeps into the soil, water soaks into the soil.
Yeah, it just says water.
Water gets into the ground. You can shorten it. We good? All right, all of this is already written for you. So just so you have an idea, you've got all this different water that's underground. Some of it comes up to the surface in streams. That's considered a discharge area because it is discharging, it's coming out of the ground. You have any area where you don't see water is a recharge area because when it rains, it can seep through. And then we're going to eventually talk about all these different aquifers here and waters. Another way that we can get water out is through pumps like our wells, and we're going to talk about that later. But all of that information is right there. And let's see, it's already typed. We're not going to deal with that. Okay, so I want to see if this here. All right.
Inside?
What? Okay. I guess you can leave the class pit. All right, you're going to use this and fill in that chart right there. No, on this little chart right here. I just went back here so you could fill it in. Thank you, Caleb. Okay, we keep it. Okay, so if you look on your paper, on the left-hand side, this first blank is going to be condensation, transpiration, because it's coming out of the trees.
What are you doing?
Condensation is going in, it means it's making the clouds. When the clouds get heavy enough, the middle one at the top is precipitation. You're going to get surface runoff and subsurface underground runoff. Then you're going to get accumulation, which is what is looking like a pond, ocean, or something here. Then you're going to have evaporation and back to condensation. So fill in your chart using that up there. Now we have and then Friday, you were to that you continue to finish up today, except Tammy is down. And they're working on it. It hasn't come up yet. It's whoever developed Tammy, it's their issue. So we're gonna talk about groundwater, wells and springs, at least. I would like to get, talk a little bit about pollution, but we'll see how far we get. So when you get it, if you will, get this filled in first so that we can move on. Go ahead and flip over to the one when you're done that says groundwater wells and springs. Wells and springs should be nice. Oh, do you have two of the same?
Yeah.
Oh, that's for extra wind. I was like, I was missing an extra copy.
Yeah, maybe.
Subsurface below the ground. So this little incline, as it seeps under, it's gonna run down where it's going to accumulate. Bit of paper, we got one more precipitation. Okay. Precipitation, and then. Okay. You'll just have to get what you miss. You don't need to be making comments right now. Yes. All right. Flip over. Like this. So we need to understand what we mean by groundwater. Groundwater is just water that's under the surface. It's under the land. And it's often stored in, and this is what you're going to put, saturated pores of soil or rock. So what you're putting in the blank starts with saturated. Saturated pores of soil and rock. I've got some terms here. Are you good, Caleb? Aquifer. If you look here, any of this water underneath is kind of part of an aquifer. This is where you have permeable. Permeable means there's spaces around the rocks. It's going to allow the water to seep through. So permeable rock layers are sediments that transmit groundwater freely, and it's where we get our well water. So let's see what we put in the blank. Permeable rock. So what you're putting in the blank is permeable rock. Layers. Now, an aquifer can be confined or unconfined. Unconfined are the ones that we can actually get to because the upper level is not uh, bedrock. It's not rock that water can seep. It's water. It's rock and soil that water can seep through. So it's unconfined. It allows for infiltration. Some aquifers are confined, and they have a bedrock on the top, and you can't get to those aquifers. All right, so everybody got that? All right, porosity, and here's some pictures in your notes of different porosity. It's the percentage of total volume of rock or sediment that consists of pore spaces. Pore just means open. So pore spaces. That is on the right page until you move your papers. Porosity right here. So consist of pore spaces. So sorting rocks into porous and non-porous. So this is kind of how we do this. If you have lots and lots of rocks that are very close together and fit together very well, and there's not a lot of space between them, that's low porosity. Water's going to have a hard time traveling through that. Here is high porosity. You see more blue, which is the water. The rocks are spaced further apart. Water can seep in through it. So that's sort of how we determine rocks, either low porosity, very tight together, doesn't let a lot of water through, or high porosity, more space for water to go through. Permeability is the material's ability to transmit fluids through, transmit fluids through interconnected pore spaces. The fact that water can seep through those open spaces, that's permeability. Now, groundwater will move slowly when there's not a lot of that open space, and it will move faster when there are lots of open space. So fine clay, for example, is impermeable because that material is compacted together. There's not a lot of space. Water will not seep through. Clay on the other, or sand on the other hand, water can seep through it. And a mixture of the two, water can get through it. So fine clay is impermeable, is the other blank. Impermeable. The other blank, fine clay is impermeable. Flip your page over. All right, aeration is air. That means can it have air in it? Aeration, so zone of aeration. This is the region between Earth's surface and the water table. So that's what goes in the blank, between Earth's surface and the water table. All right, we skip down to here. Here's water table. It tells you what that is. But these bullet points right here are kind of above where it puts the water table for you. The water table is the level below which the ground is saturated with water. So if you were digging a hole, trying to dig a well, and you got to where you saw water, that's your water table. Anything below that, it's going to be saturated with water. So look at your bullets. A high water table goes in that next blank. A high water table during periods of heavy rainfall or rapid snow melt can lead to flooding. So areas that are the water table is closer to the surface, During heavy rainfall and rapid snow melt, it can cause flooding. Uh, because the ground is already saturated, it cannot hold any more water, and so the ground becomes um, covered in water, which is flooded. So water table, zone of aerations, everybody have those two blanks. All right, zone of saturation. This is the area. Oh, thank you. All right, this is the area where water fills all the open spaces in the sediment or rock. This is where groundwater is located. So the area where water fills all of the open spaces. Water, then it fill it right in, fills all of the open spaces. So it's saturated. If you can see the picture over here, there's a dotted line where the water table is. Solar saturation is right where the so anything is saturated is
You must find a deep lake and go to.
so if you notice, A here is going to be closer to your water table than B here. But the zone of saturation is where all the water is below the water table. All right, so there's a few ways that we interact with groundwater. Sometimes we need to get groundwater up to the surface and an ordinary well. I still use well water at my house. I live out in the country. Well has not been contaminated, so we have well water. So ordinary well, this is just a hole that's dug below the water table and then fills it with enough water. In the olden days, you would throw a bucket in and bring up the water. Now we have pumps that pumps up the water into a holding tank, and then that holding tank is then pumped into our house. So when you have lose electricity, you also lose water. Um, if several wells are drilled in a given area, it can deplete the groundwater. So if you have multiple wells in one area for that area and you use a lot of water, it can deplete that groundwater. What do we need to fill in there? Pumping is necessary and then deplete groundwater. Good. Now there's something called an artesian well, and this is where groundwater just naturally rises on its own due to pressure out of an opening in the ground. It's called an artesian well. That's a little bit different. Geysers are a little bit different.
I said it's like it.
Yeah. Oh, okay.
It's exactly like it, but
Works under the same kind of concept. What happens is the pressure comes between when the water's being sandwiched between impermeable rock layers, and when enough pressure's been exerted, that water forces its way up, and you don't really need pumping to get that. It's just naturally coming up.
so how are you supposed to get it when it comes up?
I don't know if this is one that you actually get. A lot of times these may be underneath, and it may be what feeds a pond, springs feed ponds. I don't know if you'd actually use it for like drinking water, but it's just a term that they've given to
Well, if you
these.
could get it,
You'd have to find a way to capture it as it comes out.
basically put the top of a well on there and And put hoses on top of the well.
well, then you'd probably still have to have, you would have like a tank, but you still need a pump to pump it out. So you'd have to have a collecting tank, and then you'd have to have a pump to pump it to where you needed it.
I'm staying today. I'm staying after school.
Yeah, he's staying with me today. I forgot to tell you this morning, and I bet we forgot to tell the bus. Yeah, I forgot to tell the bus. It slipped my mind with everything that went on this morning. Shoot, that's gonna make me upset. It was my fault.
I totally forgot I was staying after school today.
But I also messaged principal, so anyway.
Do it while I'm outside.
Okay. Subsidence. Um, subsidence, yeah. This is when Earth's surface sinks because of geologic, that means yes, sinkhole, naturally occurring, or man-made, something we've done can cause this. So man-made means we would pump enough water out of the ground that the area around it becomes sort of fragile and it sinks. We call them sinkholes. So subsidence.
They're also called natural disasters.
Um, subsidence. Subsidence then is you're going to put sinking of the Earth's surface. The sinking of the Earth's surface is what you're going to put in that blank.
Wait, is the earth?
Right here. Sinking of the Earth's surface. Now, if you, it's interesting, let's see how we're going to flip this. When you flip your paper, you turn it to the back, you need this page right here. You're going to see some pictures of sinking subsidence. All right. So, in North Carolina, so the little section under the pictures. Why is this an issue for North Carolina? It can lead to destruction of property and habitats, not just in North Carolina, but anywhere. Yes. Destruction of property and habitats. So you can see here that this is breaking the road away. Here you've got sort of in the mountains where it's kind of it's sunk down there as stuff is washed away. So destruction of property and habitats is what it causes. And that can be anywhere, not just North Carolina.
But we're the main spot, right?
More, I would say, it really depends. If you notice, the pictures that are put here, they tend to be on an incline. So if you've got an area that's not draining well, and over time, it can cause enough water to seep in to cause these damages.
So it's like a dog digging a hole.
All right, springs, natural springs. Natural springs. This is where you have impermeable, it's kind of like an artesian well, but it's not enough pressure for it to just be spurting out. But you've got water that emerges at the top of the ground. A lot of springs will feed your ponds or your lakes. You may have some springs that do that. These are, you just have, let's see, rock forces groundwater to move laterally and emerge, and the blank didn't show up there for some reason. Move laterally is what you're putting after groundwater two. So remember, I'm recording. The move laterally goes in that empty space. Everybody got moved laterally?
Yeah.
It's just two words, move laterally.
Legislature and ally put together.
Move laterally. All right, hot springs. Hot springs are springs that are going to have higher temperatures. The temperatures will increase on into the earth, and water from hot springs sort of originate. They're going to originate deeper in the earth, where it's close to the magma that is extremely hot, and so it keeps the springs temperature warm or hot. And there are some of these natural springs that they let people go, I guess, and sit in or enjoy as a
Kinda like
tourist
hot
attraction. But hot springs, so it's going to be close to the magma. The water comes up and is heated. So hot springs that you're going to put temperatures increase into the earth.
All they have to put is just
Deeper
inside,
inside.
it's deeper inside. Yes, they have to put.
Oh, I was looking, thank you, I was looking down one. And water from hot springs just originate deeper inside the earth. I jumped down the geyser, that's why I was like, deeper inside the earth.
It has our already on there.
All right, a geyser. A geyser is not, it spouts out like an artesian well, but it's actually a spring. It's a hot spring that will periodically erupt. So there's a small opening in the crust, that's the Earth's surface, and pressure is going to build up until an eruption happens. One that you've probably heard of is Old Faithful in um, Yellowstone National Park. So hot springs that
That's exactly what I thought about.
periodically erupt. Periodically erupt. So, take this out. groundwater, but it's limited. And so there are ways that we as humans have polluted our groundwater, and we've got to be careful with this. Uh, my bullets are down toward the bottom. So fertilizers, fertilizing our gardens, our fields. When it rains, it runs off. It can seep in and get into our groundwater. Pesticides, use of pesticides also can get into our groundwater. Sewage systems. So in the city, you're a part of a sewage system goes to the plant that then cleans it up and all that stuff. But out in um, the country, you have septic systems, you have tanks in the ground that all your sewage goes in, and those can leak when they get older or something happens and they crack. Industrial chemicals leaking into arsenic, and this is why a lot of people where I live, we actually have county water that comes. It's piped out there, but we don't hook on. Our well
Natural.
is not has not been contaminated with arsenic. A lot of the wells in Stanley County, natural wells that people used to be able to use, have been the water quality has gone down due to arsenic specifically. Um, and so that's why it was a big push to get the county water out to everyone. All right, so what that leaves for tomorrow, figure out how my paper is here. Solution. There's about 10 minutes left. Some of you still owe me some videos. So you need to look to make sure if you owe me videos, you get them in. I'm working on them. We can't do the Cami stuff right now, but you can at least do the videos. Also, just so you know, anything after November 11th, 20th, nothing can be made up from November 18th backwards. So if you're behind, you got to get everything called up. And then also we'll be doing some unit recoveries for those who have been haven't failed. You'll get assigned some units in Edmentum to give you an opportunity to get your grade back to passing. So just some things to look up with. So I'm going to stop recording.